Hello, we've had a request about a problem from the piecewise defined function, section 3.4. This is not number 30. So if you look at number 30 in the book, it won't be exactly this one, but it's a very similar to that problem. And what we're trying to do is we're trying to do four things with this function. We're trying to find the domain, the x-intercepts, the graph, and finding the range based on the graph. Now remember, the domain are the x-coordinates. The range is the y-coordinates. And the graph, of course, would be the visual representation of this. It's the solution to this function. And x-intercepts, and we may go ahead and find the y-intercepts as well. So anyway, so now you don't have to do all of these in the order that you have. As a matter of fact, I like doing the graph first. Okay, then I'll come back and look at the domain based on the graph, the range based on the graph, and kind of do like a visual inspection of the x and y intercepts. So I kind of start with C when I do these problems myself. So if you look at the function is defined to be 5x as long as x is not equal to 0. So from negative infinity to positive infinity, there's only one place where it does equal 0, and that's at the origin. So for over to the whole domain, the function is mostly defined to be 5x. So 5 times whatever you put in other words. So what I would do is I just kind of go back to 2.3 when we talked about how to graph lines and look at the y-intercept, which in this case 5x. So the y-intercept is at the origin, and the 5 is the slope. So you'd use the rise or the run, which is what I like to do. So this is kind of like 5 over 1. So it's rise 5, 1, 2, 3, 4, 5, and run 1. And of course, 2 points determine the line. And I'm not a very good line drawer, but more or less that's what it is. Okay, so line 5x is right there. Now that's if you place no restrictions on the domain. But this is only 5x as long as x is not equal to 0. But like I said, only at the origin is where it's not equal to 0. So it's equal to right there. I need to put a hollow point right there. And what that hollow point indicates is it's not defined there, because it's only defined to be 5x as long as x is not equal to 0. It's kind of like two rays, if you will, kind of fused together. Okay, but there's a disconnect at the origin. At that disconnection at that point, it's going to actually be defined to be 4. So when x equals 0, this is x equals 1, x equals 2, this is x equals 0, the output is 4. So you just have like a standalone point up there. And it is a function. It passes the vertical line test everywhere, even including the y-axis. If you draw a vertical line right on top of the y-axis, it hits this point, but not this point because it's hollow. So this piecewise defined functions, for the most part, it is 5x. It's this whole big solid piece with the hollow point. Now, only one point is to find something else, and that's at x equals 0, and it's y, and the y coordinate would be 4. Okay, so based on this graph, I could actually answer all the other questions quite simply. So the domain, of course, is all the x-intercepts, or I'm sorry, all the x-coordinates. And so therefore, you have an x-coordinate of 1, you have x-coordinate 2. Looks like there is no x-coordinates that are not allowed. So the domain here will be all real numbers. Or you could just simply put the capital R, bold R, whatever you're going to call it. Now B is the x-intercepts. Well, x-intercepts is the place where it crosses the x-axis, of course. And if you look at the graph, I don't see it crossing. And you're like, well, yeah, it is. It's crossing right there at the origin. No, but remember, that's a hollow point. Hollow point means that point's not included. So it goes up to that point, and it goes up to that point, but it doesn't have a point on the x-axis. And since there's no point on the x-axis, there are no x-intercepts. You just put none. Now, y-intercept is the place where it crosses the y-axis. And on the line itself, it doesn't cross the y-axis again because there's a hollow point there. But there is a y-intercept, and if you look very closely, there is a point on the y-axis, and it's at 0, 4. And you have to write it as an ordered pair. You can't just say y equals 4. That's more of a line, okay? 0, 4 is a point. So when they're looking for an intercept, they're looking for a point. So if they're looking for an x-intercept, it would be some number, comma, 0. And if they're looking for a y-intercept, it's 0, comma, some number. In this case, 4. Okay? So those are the x and y intercepts. C, done. Yeah, I've already graphed it for us. Now D is the y coordinates. The y coordinates here, if you look very closely, there's a bunch of y coordinates up here that's going in the positive direction and the negative direction. You have a y coordinate of 4, actually twice, but that's okay. So every y coordinate is established except for one. Think about what that one is. The only y-intercept that you don't have is the y coordinate you don't have is the 0 itself. Okay, it's all the negative numbers, all the positive numbers, 4 twice, but not 0. All right, so the range is negative infinity up to 0, union 0 to infinity. That's an interval notation. I'm not a big fan of that, to tell you the truth, when it comes to problems like this. If I'm looking for the range, I'd say that's all real numbers except for one number, and that is all real numbers except for 0. Now, for you guys who are using My Math Lab, they'll probably want the answer like this. For the rest of you guys, you can just put all real numbers not equal to 0. Okay, so the My Math Lab people might have this option, x not equal to 0. Oh, sorry, not x, but y not equal to 0. You might have that option in your work on the My Math Lab on the course Compass. So, but either one of these would actually do. Okay, and that's it.